Hey 2Ds, we're going to start talking this week about how elements react to form compounds. And the whole part of the story is just talking about finding the closest noble gas. So, the first part about the story is that we need to know that all elements in the same chemical family have the same number of electrons in their outer shell. So, if I'm in oxygen's group, oxygen's in group 16, oxygen has 6 valence electrons. If I'm below oxygen, if I am sulfur, which is also in group 16, I will also have 6 valence electrons. If I'm an alkali earth metal like beryllium or magnesium, they're in group 2 and they each have 2 valence electrons. So the key part here is that if I'm in the same chemical family, I'm going to have the same number of electrons in the outer shell. Now, earlier on, it was recognized that helium, neon, argon, krypton, xenon, radon were the most stable elements. And the question that came up was why? In fact, argon here is about 1% of our atmosphere. And it wasn't discovered until about 200 to 300 years ago, so pretty recently, believe it or not. So why are these stable? Well, they are stable because they have full energy levels. So they have full valence shells. And that's the key point here is that if you've got a full energy levels, you are going to be stable. So let's take a look at some Bohr-Rutherford diagrams. So here's a Bohr-Rutherford diagram, and you can see, remember, our filling of our shells is 2 electrons in the first shell, 8 in the second. If there was a third, you'd have another 8 here, so 2, 8, 8. You can see that this element is full. It's got 2 electrons in the first energy level and 8 in the second. Now, what element is this? Now, we go to the protons to figure out what element it is. It has 10 protons in the nucleus, and therefore we look up element number 10 on the periodic table, and this is neon. Again, it's got 10 protons. The atomic number goes in the bottom. Now, what is the mass? We add up 10 plus 12. 10 plus 12 is 22, so the mass is 22. And does it have a charge? I've got 10 positive protons, 10 negative electrons, so it has no charges. Notice this element is stable. It has full valence shells. It's got full energy levels. 2 electrons in the first and 8 in the second. Let's take a look at another element. Now, notice what changes here. So if I change into another element, you can see what changed was the nucleus. What didn't change was the number of electrons. So what element am I talking about here? Well, what is element's got 6 protons in the periodic table? This is carbon. Now, the mass of this, again, the 6 goes down below. The mass of this, 6 plus 8, would give us the mass number, so this is carbon 14. Now, notice, this carbon has full valence shells, so it has 2 electrons in the first, 8 in the second. There's a total of 10 negative electrons. I've got 6 positive protons. The difference between 10 negatives and 6 positives is minus 4. So this is an ion of carbon. We call this the carbide anion, and it has a charge of minus 4. Now remember, the charge compares the proton number to the electron number. So if my charge is negative, I've got more electrons. If my charge is positive, I would be a cation, and I'd have more protons than I'd have electrons. Okay, so let's take a look at the next stable noble gas, which is argon. Argon, you can see, has got 3 energy levels, and it's got full electrons in each energy level. It's got 18 protons in the nucleus and 18 negative electrons. If I switch elements here, notice what doesn't change is the number of electrons. Here is another element. It's going to be an ion, and it has full shells. Now, what element are we talking about here? Well, we have to use the protons to figure out what element we have. So what element has 15 protons on the periodic table? Well, this is phosphorus. And you can see the phosphorus has a charge in this case here. I only have 15 positive protons. I have 18 negative electrons. The difference between 15 positives and 18 negatives is 3 minus. So my charge of this phosphorus anion is 3 minus. Now, instead of calling this phosphorus, this ion is actually called phosphide. It ends in IDE. We're going to talk about this on our next screen. So here are 2 elements here. What elements do we have? Well, 1 proton here, this is hydrogen, and 2 protons, this is helium. Now, how atoms of other elements become more stable is that they acquire the same electronic arrangement as the noble gases. Noble gases are sometimes called inert gases because they don't react with anything. So how can this hydrogen become like its closest noble gas, which is helium? Well, how does it do this? So there's the question there. All it needs to do, it can't gain another proton because it won't be hydrogen anymore. So what it does is it just gains one more electron. So it can gain an electron to form, now it's going to be an hydride anion. So it does this. So here it is here. Now it gains an electron. It has a full first energy level with 2 electrons that's got the same number of electrons as our closest noble gas, which is helium. It is now isoelectronic to helium, its closest noble gas, and this would be stable. Now this is no longer hydrogen. It's an ion. In fact, this is a hydride ion. So again, anions end in IDE, and it's going to be much more stable than a single hydrogen atom. So there is our ion symbol right there. Hydrogen, the symbol, and the 1- charge in the upper right-hand corner. So let's do a couple more of these. So here's an element here. What element do we have? Notice I've dropped the neutrons because it's not part of our story, but I've got 8 positive protons, so this is oxygen. What is oxygen's closest noble gas? Well, 8 protons is closest to our noble gas 10. So its closest noble gas is neon. So how can the atom below become more stable? Well, we have to figure out what is the nearest stable atom. And in this case here, it's neon. How many electrons does neon have in its outer shell? Well, it's got 2 electrons in the first and 8 in the second. So what does oxygen need to do to become like neon? Well, this 6 electrons here needs to be 8 electrons. So how many electrons does it need to gain? Well, it's going to gain 2 electrons to be isoelectronic to its closest noble gas. So there it is there. It gains 2 electrons. It now has the exact same number of electrons in its shell, so 2 and 8, as its closest noble gas, 2 and 8. So this oxygen is no longer just an oxygen neutral atom. It's now gained 2 electrons, so it's become an anion, and its symbol would be O2-. Now again, this is no longer oxygen, it's an anion, so we end in IDE. This is an oxide ion. Let's take a look at this element here. So just give you a second, what element is this? What element on the periodic table has 4 protons? Well, if you take a look on the periodic table, this is beryllium. Now, how can the beryllium atom become stable? Well, we have to ask the question, where is its closest stable atom? In the case of beryllium, it is not all the way across that row. It's not neon. It's actually back in the first row. It is helium. Now, how many electrons does helium have in its outer shell? Well, helium, here it is here. It's got 2 protons and 2 electrons. How can this beryllium have the exact same number of electrons as its closest noble gas, helium? Well, what it does is it gets rid of these 2 electrons in its valence shell. So if I take this and remove those electrons, I've now formed an ion. Now this is a cation. It's going to be positively charged, and it's going to be a beryllium cation. It is going to be Be 2 positive charge because I've got 4 positive protons, 2 negative electrons. The difference there is 2 positives. Notice the thing about cations is we don't change the ending of cations. It's beryllium ion, or you could say a beryllium cation. We don't change the ending to IDE. So it lost 2 electrons. Let's do one more. Again, we've got an element here. It's got 12 positive protons, and you can see it's got the exact same number of electrons, 12. 2 in the first, 8 in the second, and 2 in the valence shell. So the question is, how can the atom below become more stable? Well, you have to ask the question, where is its nearest stable atom? Well, 12 protons, this is magnesium. Magnesium's closest noble gas is actually 10, so it's neon. So here is neon here. So how many electrons does neon have in its outer shell? It's 2 and then 8. So what does this magnesium atom need to do to have the same number of electrons as neon? Well, it needs to lose 2 electrons. So it takes those 2 electrons in the valence shell and it loses them. And now we've got an ion. It's a cation, so we don't change the ending or anything. So magnesium ions is Mg2+. So it lost 2 electrons, much like the beryllium in the previous example. So it is known that both of these are more stable than their neutral atoms. They have full valence shells. That's the lesson for today. So again, all of these atoms, if you looked at magnesium and beryllium, they're actually in the same chemical family. And if you take a look on your periodic table and the ion chart, you can see that all alkali metals have an overall charge of 1+. This is the alkaline earth metals, magnesium and beryllium. They're all 2+. If you go back to oxygen's group, oxygen would be 2-, sulfur is 2-, and all the other elements in their family are going to be 2 minus. And if you look at the halogens, so fluorine, chlorine, bromine, iodine, etc., they all have a 1 minus charge. So all atoms in the family all have the same charge. So again, these are all more stable than their neutral atoms because they have full valence shells. That's the big lesson from today. Full valence shells is what we're looking for. What is its closest noble gas? Is it element 2? Is it helium? Is it element 10? Is it neon? Or is it element 18, argon? Thanks.